Hello and good morning. Welcome to my YouTube channel, my remote class. I have already started taking classes on biomolecules and I have posted a couple of videos on it in my YouTube channel. Today I am going to take class on carbohydrates. You know that carbohydrates are the primary source of energy for the cell and it is also the main structural components of plants. So let's start with carbohydrates. Carbohydrate is one of the most important biomolecules. Why is it so? Because number one, it is the source of energy for the cell. It is the source of energy. Secondly, it is the major structural components of plants. Thirdly, glucose is the immediate source of energy. Fourthly, reserve or stored energy in the form of glycogen. So these are the salient features which carbohydrates exhibit, and for that reason carbohydrate is one of the most important biomolecules. Now all the carbohydrates have certain salient features. Number one, they are made up of carbon, hydrogen and oxygen, and the simple ratio between hydrogen and oxygen is 2:1. But there are some exceptions. We will discuss about that, and there is a general formula of carbohydrate, that is CnH2O whole N. So these three things you have to remember. One, carbon, hydrogen and oxygen are the three main elements which constitute carbohydrates. Carbohydrates, the simple ratio between hydrogen and oxygen is 2:1, and the third one, the general formula of carbohydrate is CnH2O whole N. Now there are certain exceptions. For example, formaldehyde is made up of carbon, hydrogen and oxygen. The formula is HCHO. So here we can see there is hydrogen, there is carbon, there is oxygen. Secondly, acetic acid. Formula CH3COOH. Third one is lactic acid. CH3CHOH. In all these three cases, we are finding that there are carbon, hydrogen and oxygen. Carbon, hydrogen and oxygen is common in case of formaldehyde, in case of acetic acid, in case of lactic acid. But they are not regarded as carbohydrates. So what is the reason? As I said, that they are made up of carbon, hydrogen, oxygen, and the simple ratio between hydrogen and oxygen is 2:1. The general formula is CnH2O whole N, but there is another thing which has to be present to satisfy the definition of carbohydrates. Actually, this is the must one. What is this one? This is carbohydrates are optically active polyhydroxy aldehydes or ketones or producing similar units. So this is the definition of carbohydrate. Definition of carbohydrate, that they are optically active polyhydroxy aldehydes or ketones or producing similar units. Now formaldehyde, acetic acid, lactic acid, all of them have carbon, hydrogen and oxygen, but they are not polyhydroxy aldehydes or ketones or producing similar units. So they are not regarded as carbohydrates. Now, as I said earlier, that the general formula of carbohydrate is CnH2O whole n, where the n equal to any integer from 3 to 7. For example, if there is n equal to 3, then it will be C3H6O3. That means it's a triose sugar. There are exceptions where we will not get 2:1 ratio. What are these examples? The examples are deoxyribose, the formula of which is C6H12O5. Then there is rhamnose, this is again has the same formula, and digitoxose, C6H12O4. In all these cases, we are finding that the ratio between hydrogen and oxygen is not 2:1, but all these three are examples of carbohydrates. So these are the exceptions. Now let us classify carbohydrates. Carbohydrates can be classified into monosaccharides, then we have disaccharides, then we have oligosaccharides, and finally we have polysaccharides. So these are the four one. Number 1 monosaccharides, number 2 disaccharides, number 3 oligosaccharides, and number 4 polysaccharides. Now let us go one by one. Actually, monosaccharides are the simplest sugars which cannot be hydrolyzed further, So these are the simplest sugars, monosaccharides. Now, what are the examples of monosaccharides? Glucose, then you have fructose, then you have galactose. And what is the general formula of it? CnH2O whole N. This is the general formula of monosaccharides. So what we have learned, that carbohydrates can be divided into four. One is monosaccharides, one is disaccharides, another one is oligosaccharides, and finally the fourth one is polysaccharides. Now what are monosaccharides? Monosaccharides are the simplest sugars which cannot be hydrolyzed further. The examples are glucose, fructose, galactose, and the general formula of it is CnH2O whole N. Classification of monosaccharides. Classification of monosaccharides. How can we classify monosaccharides? We can classify monosaccharides according to the number of carbon. According to the number of carbon. For example, we know that CnH2O whole N is the general formula of monosaccharides, and we can put any number between 3 to 7 for N. So if N equal to 3, if we put C equal to 3, then we call it triose. If we put C equal to 4, then we call it tetrose. If there are 5 carbons, we call it pentose. If there are 6 carbons, we call it hexose. And if there are 7 carbons, we call it heptose. For example, this one, if we put 3 here, then what will we find? We will find C3H6O3. That means this is a triose sugar. In case of tetrose, it will be C4H8O4. In case of pentose, it will be C5H10O5. In case of hexose, it will be C6H12O6. In case of heptose, it will be C7H14O7. So I hope you have understood all these things. Now we can classify monosaccharides on the basis of the presence of aldehyde group or ketone group. On the basis of aldehyde group or ketone group. If the aldehyde group is present, we call that monosaccharide as aldose, and if the ketone group is present, we call it ketose. Let's see how it can be done. For example, this is a triose sugar. Now here you can see that in C1 position the aldehyde group is present. So it is known as the aldehyde group is present, so this sugar is known as aldose. Whereas in case of this one, we are finding that ketone group is present in carbon position 2, so we call it a ketose. So if there is aldehyde group, we call that sugar as aldose. If there is ketone group, we call it a ketose. Is it clear? Okay, so let's move to another one. Now there is an interesting thing that the nomenclature between these aldose and ketose varies. For example, C3H6O3, this is glyceraldehyde. Glyceraldehyde is an aldose sugar, but when it becomes ketose, the name changes. Dihydroxyacetone. Is it clear to you that C3H6O3 is the formula of glyceraldehyde, as well as for dihydroxyacetone? But if it is aldose, then we call it glyceraldehyde, and is ketose, then we call it a dihydroxyacetone. Another example, C4H8O4. This is an example of tetrose sugar. If it is aldose, we call it erythrose. We call it erythrose if it is an aldose. And if it is ketose, we call it erythrulose. Another example, if it is aldose, we call it ribose. If it is ketose, we call it ribulose. So these are the differences between the naming of aldose and ketose. Or there is another classification of monosaccharides, that is on the basis of 6-member carbon rings or 5-member carbon rings. If there are 6 members, then we call it pyranose, and if there are 5 members, we call it a furanose. So let's draw these two. This is your pyranose. And what about furanose? One, two, three, four, 5. Here 1, 2, 3, 4, 5, 6. So this is 6 members carbon rings, and this is 5-member carbon rings. This is furanose. This is 5-member. So if the hydrogen is on the upper side and hydroxyl group at the lower side, then we call it alpha glucose. whereas the hydroxyl group is present on the top side and hydrogen is present in the bottom side, then we call it a beta glucose. One question came in Neet that which is the most abundant sugar present inside the nucleus? Which is the most abundant sugar present inside the nucleus? The answer is pentose. So this is D glucose and this one is L glucose. Now actually what happens in case of dextrorotatory glucose, the structure looks like this one. Let me draw. Now this is your carbon position 1, 2, 3, 4 and this is 5 and this is 6 and this is 1, 2, 3, 4, 5 and this is 6. Now look here. Here you can find that OH group is present on the right hand side and here it is present in the left hand side. Now if light passed through a prism, and if this test tube contains D glucose, then what will happen? The light will be deviated on the right side, whereas if it deviates on the left side, then we call it L glucose, and if it deviates on the right side, we call it D glucose. So this deviation is taking place on the right hand side, so it is D glucose, and if it deviates in the left side, it is then we call it L glucose. Now let's talk about disaccharides. Disaccharides are made up of two monosaccharides. So two monosaccharides togetherly form a disaccharide. Now what are the examples of disaccharide? Sucrose, then we have lactose, then we have maltose. Now sucrose is also known as table sugar. It is also known as table sugar or cane sugar, or beet sugar, or commercial sugar. Lactose is known as milk sugar, and maltose is known as malt sugar. Now let's see how this can be broken down into monosaccharides. If we use this enzyme sucrase, then it will be broken down into glucose and fructose. If we use lactase, it will be broken down into glucose and galactose. And if we use maltase enzyme, then it will be broken down into 2 molecules of glucose. So is it clear to you that disaccharides are made up of 2 monosaccharides? Here we are finding that sucrose is made up of glucose and fructose, whereas lactose is made up of glucose and galactose, whereas maltose is made up of glucose and glucose. That means 2 molecules of glucose. And now what are these substances? These are the enzymes which breaks down into monosaccharides. Now let's see oligosaccharides. Oligosaccharides means the number of monosaccharides will vary from 3 to 10. For example, raffinose. It is made up of actually glucose plus fructose plus galactose. Then we have stachyose. It is made up of glucose, then fructose, and 2 molecules of galactose. Then another example, barbascose. It is made up of 2 molecules of glucose plus fructose plus 2 molecules of galactose. So here we are finding the number of monosaccharides is 3, number of monosaccharide is 1, 2 and 2, that means 4, and here we are finding 2, 1, 3 and 2, 5. So these are all examples of oligosaccharides. Finally, we have polysaccharides. Polysaccharides. Poly means many. So if many monosaccharides join together, they form polysaccharides. So these are the monosaccharides, they are joining together to form monosaccharides. Now in case of proteins, we have seen that the structural unit is the amino acid there, and in case of protein we have seen that the amino acids are linked together with a bond known as peptide bonds, known as peptide bonds. Here there is also bond we are finding here, they are linked together. This bond is known as glycosidic bond or linkage. Bond or linkage. Now let us see how it can be done. For example, this is the structure of glucose. This is one glucose and this is another glucose. Now if it is linked by this O, then we call it a glycosidic bond. This is glycosidic bond or glycosidic linkage. For example, this one 1 2 3 4. If this is carbon position 1 2 3 4, that means with this fourth one and here 1 2 3 4 5, and then here is the sixth one. Now this is number 1 position, so number 4 position of one glucose and number 1 position of another glucose, so we call it 1,4 glycosidic linkage or glycosidic bond. Now the polysaccharides can again be divided further. Polysaccharides can be divided into two categories. One is known as homopolysaccharides or homoglycans, another one is known as heteropolysaccharides or heteroglycans. Now homopolysaccharides are made up of identical monosaccharide residue, whereas heteropolysaccharides are made up of different monosaccharide residues. So the examples of homopolysaccharides or homoglycans are starch, glycogen, then we have inulin, whereas the examples of heteropolysaccharides or heteroglycans may be hyaluronic acid. I hope you have understood the structure of carbohydrates. If you have any problem or doubt, then do comment in the comment section box, and if you like my video, then do like and share this video. See you in the next video. Thank you for watching.